Okay, so for your final lesson for this unit, we're looking at solving problems. So I'm just going to go through one example with you. And more specifically for solving problems, we want to make sure that you are able to restrict the domain of functions so that you understand like what that means. So we're going to look at a problem together. We're going to actually use Desmos to graph it, which is great because I'd never expect you to be able to graph the function by hand that I'm going to give you. And then you're going to be able to answer a couple questions by accessing that Desmos graph. Okay, so the forces acting on a horizontal support beam in a garage cause it to sag by d centimeters, x meters from one end of the beam. Okay, the relationship between d and x can be represented by the polynomial function, and this is the craziness. Never be expect you to be able to graph that. Okay, so 1 all over 1800, 950x minus 22x cubed plus x to exponent 4. So graph the function using technology. So when you graph the function using technology, that is what you get. So just use Desmos. Okay, so you can see that I've just gone ahead and typed that into Desmos, and this is the graph that I get. Okay, so that is part A of this question. Then for part B, it wants you to determine the domain over which the function models the relationship between d and x. And what do you think causes the restriction on the domain? Okay, so because you're looking at the forces acting on the support beam in the garage, causing it to sag from one end of the beam to the other, the relationship between d and x can be represented by the polynomial function. Okay, so you're looking at your x meters from one end of the beam and then centimeters up here. Okay. However, does it make sense that we look at the support beam from negative into negative values? So you're like negative 1 meter of a support beam. Okay, it really doesn't. So what you're going to do on this graph is you're actually going to see that the furthest that you want your graph to go is going to be at 0, right? Because you're not going to talk about negative units for a beam in the context of a word problem, okay? And then you're going to see how far to the right you're going to go. Again, we don't want any negative values. So the farthest right before you start to go negative here again is going to be around that value, which if you actually hover over it on Desmos, it gives you a value of 8.3, okay? So the zero operation you can do if you want, or you can just look at the x-intercepts by hovering over it on the graph. Will help you get the domain. X is an element of the real number system. We use the line, so I'm going to change that to a line such that x is greater than or equal to 0 and less than or equal to 8.3. Okay, remember what I just explained. So the deflection of the beam cannot be less than 0, and the domain is determined by the length of the beam, which appears to be approximately 8.3. So you can't talk about the negative aspect of a beam, and that's why you restrict it there. Okay, so that is just from looking at our graph on Desmos. And then for C, it wanted you to determine the maximum deflection of the beam. So you're just going to look simply at your graph and the highest that it goes. So I've circled that point there on from your Desmos graph. This is a zoom in there too that you can see is about 8.3 there. Okay, for the last question. But determine the maximum deflection, so you're just going to look at the maximum, and it is going up to be about 1.5 because this is at 1, and then halfway between 1 and 2 is 1.5. So it's at 1.5, so the maximum deflection of the beam is approximately 1.5 meters. So that, again, is using technology first to graph it, and then you should be able to answer questions by looking at that graph. Okay, so again, a shorter lesson, but lots of practice for homework. Right now it's 1 to 13 as I'm recording this video, but make sure you check the outline to make sure that I haven't changed it. Okay, good luck. Let me know if you have any questions.